Hello everyone, this is Shreya. I am going to explain the concept of probability. In this video, I am going to explain the basics of probability, and once the basics will be clear, you can easily solve the advanced level probability questions. I am going to cover entire probability from basics to advanced. So in this channel, make sure you subscribe to this channel and press the bell icon. Now coming to the basics of probability, we first need to understand two things, that is what is sample space and what is events. Coming to the events, let's take an example. Toss a coin, output may be head or tail. Such experiment are random experiment. Means when we are tossing the coin, we know there are only two possible outcomes that can come, that is either head or tail. But once we flip the coin, we don't know what is going to come. It can be head or tail, means we can't predict it. So we will be knowing set of all possible outcomes, but we might don't know in advance what is the outcome we might get. Now coming to the sample space, set of all possible outcome is called as sample space. Let's take an example, then it will be more clear to you. If random experiment is tossing a coin, then sample space is set of all possible outcomes, that is head and tail. If random experiment is rolling a dice, then sample space is 1, 2, 3, 4, 5, 6. Means when we are rolling the dice, then it can come either 1 or 2 or 3 or 4 or 5 or 6. That's why these all outcomes come together are called as sample space. And when we are rolling the dice, we can't predict what is going to come. That's why rolling a dice is random experiment. If random experiment is tossing two coin, let's take we have coin 1 and coin 2. Coin 1 has two possibility, head and tail, and coin 2 also have two possibility, that is head and tail. So total possibility is 2 into 2 equal to 4. And for this sample space is this one, means in coin 1, once we flip the coin 1, we can get a head, and when we are flipping coin 2, we may get a head again, and likewise you can arrange this. Let's take one more example. If random experiment is rolling two dice, means we are having dice 1 and dice 2. Once we roll dice 1, we have total 6 possible outcomes, that is once we roll dice 1, we may get 1 or 2 or 3 or 4 or 5 or 6. Similarly here for dice 2, we have 6 possibility, so total we have 6 into 6, 36 possibility. That is sample space is that one. And you can do it like once we roll the dice 1, we may get 1, and once we roll the dice 2, we may get 2. We may get 1, and once we roll the dice 1, and we may get 1, and once we roll the dice 2, we may get 2. Likewise you can arrange this. Now probabilities of events. Let me flip a coin. Sample space for this is set of all possible outcomes. Once we flip the coin, we have only two possible outcomes, that is head and tail. That's why sample space is head and tail. Event even, probability that head will come. For this we use the formula, that is number of all possible outcomes for event even upon number of total outcomes, that is size of sample space. Probability that head will come up, for this event the outcome will be 1, because there is only one head when we flip a single coin, and the total possible outcomes, that is size of sample space, is here 2. That's why the probability for this event even equal to 1 by 2. Similarly, probability that tail will come up, we use the same formula, and when we flip the single coin, the probability that possible outcome for this event that tail will come is 1. That's why probability of E2 is 1 by 2. Probability of sample space is, for this example, is 2 by 2. Sample space means the entire thing, either head can come or tail can come. That's why total possible outcomes equal to 2 for this event, that is given sample space probability, and upon size of sample space is 2. So there are some important things that we need to know, that is probability of sample space is always 1 and probability of any event always lie between 0 and 1, because events are basically subset of sample space, and if sample space itself have probability 1, then how can any event can have probability greater than 1? Because all the events coming from the sample space itself, means events are subsets of sample space. Therefore any event probability can never be greater than 1. It always lie between 0 and 1. Now, in case if two events E1 and E2 are not mutual exclusive, means there is something common between them. That is, we have sample space, and inside this sample space we have two events, that is event E1 and event E2, and there is something common between them. That's why they are not mutual exclusive. For this we can say that E1 union E2 equal to E1 plus E2 minus E1 intersection E2. E1 union E2 means E1 or E2. Therefore we are adding E1 and then we are adding E2. And when we are adding these two, we can notice that we are adding this part 2 times. That is, E1 intersection E2 are added 2 times. Therefore we have to subtract it once. In terms of probability, we can write it like this, and this formula is very important. You don't need to by heart this formula, you can simply understand this with the help of this Venn diagram. And in case if two events E1 and E2 are not are mutual exclusive, means there is nothing common between them. That is, we have sample space, and inside this sample space we have two events, that is E1 and E2, and there is nothing common between them. That's why they are mutual exclusive. For this we use the formula E1 union E2 equal to E1 plus E2. We don't need to subtract here E1 intersection E2 because there is nothing common between them. And in terms of probability, we can write it like this. These two formula are very important, and you can simply understand these two formula and mutual exclusive, not mutual exclusive terms with the help of Venn diagram. Let's take an example. Let's say we are flipping two coins. Therefore sample space is this one, and event E1 is event in which first coin output is head. Therefore these two are possible outcome we can get for event E1. Here we can see the first coin giving us the head, and therefore probability of E1 equal to number of possible outcome for E1 is 1 and 2. Therefore 2 upon total possible outcome, means the size of sample space is 1, 2, 3, 4 upon 4. That's why probability of E1 equal to 2 by 4 equal to 1 by 2. Event E2 is event in which second coin output is head. Therefore possible outcome for event E2 is this one. Here we can see second coin output is giving us head. Therefore probability of E1 equal to number of possible outcome for event E2 is 2, and number of total possible outcome, that is size of sample space, is 4. Therefore probability of E2 is 2 by 4, that is 1 by 2. And there is an event E3 which says that event in which either E1 or E2 happen. Therefore event E3 is E1 union E2. To find the probability of E1 union E2, we first need to know whether these two events are mutual exclusive or not. For this, we need to know what is E1 intersection E2. E1 intersection E2 giving us this one, means there is something common between them. Therefore, these two events are not mutual exclusive. So, for not mutual exclusive events, we use this formula as we seen earlier. Therefore probability of E3, that is probability of E1 union E2, will be this one, and we can substitute these terms like probability of E1 equal to 1 by 2 and probability of E2 equal to 1 by 2, and probability of E1 intersection E2 means number of possible outcome for this event is 1 upon the size of the sample space is 4. So we got the probability of E3 here. Now we can expand this formula, that is probability of E1 union E2 union E3 are this one, that is we have the sample space, and inside the sample space we have event E1, event E2 and event E3, and they are not mutual exclusive, means there is something common between them. So probability of E1 or E2 or E3, therefore we are going to add E1, E2, E3, and when we are adding E1 and E2, then we can notice that we are adding this part 2 times, therefore we have to subtract it once, therefore we are subtracting E1 intersection E2. And when we are adding E1 and E3, then we are adding this part 2 times, therefore we have to subtract E1 intersection E3. And once we added E2 and E3, then we are adding this part, that is E2 intersection E3 2 times, therefore we subtract it once. And we can notice that this part that is common between all these events, that is E1 intersection E2 intersection E3 are not added, therefore we are adding them at last. There is one more important thing, that is sample space, and there is an event E dash and there is an event E. Here E dash is basically complement of event E. Event E dash is the complement of event E. Complement of any event means the things that are present in the sample space but not present in the event E. And we can say that sample space is even union of these two events. By seeing this Venn diagram, we can write this in terms of probability, and we know that union means or, therefore we are going to use plus in place of union, and we know that probability of sample space is 1, therefore probability of E dash equal to 1 minus probability of E. This is very important formula, means probability of any event, probability of complement of event equal to 1 minus probability of that event. Thank you for watching this video. If you find this video useful, make sure you hit the like button and stay connected with me. Subscribe to this channel, and thank you.